As a system designer, you might need to run any behavior model to either design or verify your system level efficiently. Therefore, you should know why you need an IBIS model, which will become very handy in the industry specifications and standards. As you can find, there's even an IBIS open forum, which is an industry organization that manages and updates the specifications and standards for the IBIS models to make sure the whole ecosystem will align with the IBIS exchange. So, what's the IBIS? The IBIS is for Input-Output Buffer Information Specification, which originates from Intel, but the IBIS standard is driven by the IBIS forum with a few members including the system, measurement equipment, manufacturers, semiconductor, and EDA vendors, etc. The IBIS model should represent the characteristic or behavior of the device, such that the IC vendors can provide their customers for any system verification during the design or validation phases. Again, the IBIS model must mimic the device I/O behavior, which simplifies the model with an ASCII text file format of only the tabulate, watch current, and watch time information. After knowing what the IBIS model is, why do we need it? Think about a simple image for 5 seconds. Correct. A simple image leads to a shorter simulation time, which also helps shorten the time to market. For example, the system designer needs to evaluate the signal integrity SI in his design by accurately simulating I/O buffers, IC package, termination, connectors, and circuit board traces, etc. You can imagine identifying the SI-related issue during such iterations could be very time-consuming with the SPICE model, not to mention even providing a few numbers fix or improvements in the design iteratively. Therefore, the system designers are struggling in a tiny budget time with the available I/O buffers in the SPICE modeling. This was the initial motivation to come up with a simple behavior IBIS model. What else could be a good reason to use the IBIS? Think about the compatible image for 5 seconds. Bingo! Not all the companies use the same SPICE simulator from a single vendor, putting the complicated SPICE model with a few S-parameter files of the package, connector, and board traces could cause conversion issue from time to time. Furthermore, the simulator sometimes cannot get a good guidance to resolve the conversion issue, and the whole design verification become on hold. In my experience, this could be the second reason to have the simple I/O model in IBIS to reduce the compatibility concern. On the other hand, the IBIS models are supported by most EDA vendors and can be run on most industry-wide platforms. What else could be a good reason to use the IBIS? Think about the proprietary image for 5 seconds. Here we go. The SPICE model shows every circuit blocks in the transistor level, disclosing detailed information about the circuit topology, design, and process parameters. Therefore, the IC vendors may consider the SPICE model could disclose their intellectual property and resist providing the SPICE models to their customers. Then, the third concern is even worse than the previous two reasons, since the I/O model is not available for any system design or verification, which hurts cooperation in the ecosystem. So, the IBIS model indeed help protect the IC vendor proprietary and make the I/O model available to the vendors or customers in the system design. After understanding why we need the IBIS models, we may need to know what the input buffer should provide. Let's start with a simpler IX input buffer as shown here. To make an accurate IBIS model, both the package parasitic and the ESD structures must be included in the model parameters. So, the CPAC, RPAC, and LPAC are used for the package parameters. Then, the power clamp and ground clamp represent the ESD structure at the inputs. Additionally, the VI curve data defines these clamp structures, and C-comp is the input capacitance of the input pin. Then, let's go through the more complicated TX output buffer. Unlike the RX constantly on of the previous IBIS model, the TX output buffer should dynamically turn the current on and off. Therefore, the current of the pull-up and pull-down structures and any other dynamic switching structure ramp should be defined by the parameters like the VOH, IOH, VOL, IOL, and dV, dt over rising and falling waveforms, respectively. So, the pull-up and pull-down data are created from the VI curve. The remaining parameters are similar to the RX input structure, except that they define the package parasitic of the output pin and the output capacitance of the output pin. But the pull-up and power clamp data are VDD, which is supply referenced, not ground referenced. So the voltage in the tables are derived from the equation V table equals VDD minus V output. Please be advised that the VDD relative data is necessary for the symmetry as the pull-up structure depending on the voltage between the output and VDD, not the voltage between the output and ground. To capture the switching behaviors, we could create a slow IBIS and a fast IBIS model, respectively. For example, to make the slow IBIS model, we can combine minima IOH, IOL with maxima ramp time and maxima package parameters. On the other hand, to make a fast IBIS model, we can combine maxima IOH, IOL with minima ramp time and minima package parasitic. For your information, the slow IBIS is useful to determine the flight time, and the fast IBIS is handy to analyze the overshoot, undershoot, crosstalk, etc. Here are the summarized images of showing why we need the IBIS model for SerDes or any wireline C-Link instead of the SPICE model. First and foremost is the shorter simulation time, even under very big system verification, since you could initiate a great variety of IOs in a single IBIS file. Second, the IBIS model has good compatibility without converging issues. Usually, the IBIS model are supported by most EDA vendors and can be run in most industrial-wide platforms. Third, the IBIS helps protect the IC vendor proprietary and make the I/O model available to the vendors or customers in the ecosystem of the system design. Again, the IBIS are behavioral models which describe the electrical parameters as seen at their terminals. It's a black box model which reveals no internal information, unlike the SPICE model which discloses everything. Fourth, the IBIS may include the signal integrity specs like input logic threshold, overshoot, etc. The last one is that the IBIS is back compatible with models created under previous IBIS standards, and that's sustainable. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback, and please share your comments down below. Lastly, please share the video link with the people who may be benefit from it.